Hello one and all, and welcome to the Math Magic Show. In this one we're going to find the domain of f of xy equals ln of 4 minus x squared minus y squared. This is a function of two variables x and y. However, the same principle applies as always for the ln function. You want to make sure that the ultimate value of the expression within the parentheses is more than 0, strictly speaking. So how do we express that mathematically? We might begin by doing the following. We take that expression out from within the parentheses and we say 4 minus x squared minus y squared is greater than 0. It can't be equal to 0, remember, itself, because the ln function is not defined as 0. So at the next move here, we can proceed simply by subtracting 4 from both sides, or if you like, moving 4 to the right side with subtraction. Now, notice that each term, negative x squared, negative y squared, negative 4, has a negative, which means you can get rid of it by dividing through by negative 1. When I do that, I'm going to get the following. The negative x squared will become positive x squared, negative y squared will become positive y squared. The direction of the inequality will flip. That's the usual rule when you divide, for example, by a negative in an inequality. And then on the right side here, we end up simply with less than 4. So if you look at x squared plus y squared less than 4, how do we represent this? This is basically the inside of a circle, but it excludes the boundary of the circle. And it excludes the boundary of the circle because of the less than symbol. So let me show you a bit more detail here. This is my y-axis, this is my x-axis. I'm going to graph on the right side here. And now that represents the boundary of the circle. So be careful here, because the 4 that you see doesn't mean that the radius is 4. Remember, that means that the 4 is gotten from doing 2 squared. So the 2 that you're squaring is the radius. So the radius of this circle is 2. And notice, because it says less than, that over here you have a dashed line as the boundary of the circle, not a solid line. And often what you may want to try using, of course, is the point, the origin, that is. So in other words, I'm going to plug x equals 0, y equals 0 into, so when I do that here, take a look. I'm going to have the following. I'm plugging 0, for example, into the function. So when I do that, I will have ln of 4 minus 0 squared minus 0 squared. That's going to give me ln of 4 minus 0, which is then in the end just ln of 4. And what is this showing me, this ln of 4? It's showing me that when a 0, 0 goes in, I get ln of 4, which is a defined quantity. Which means that even though we use only one decimal, in reality, any other point within that boundary would make the function work in terms of making it produce a nice clean output. So that tells me that I should shade the interior of this circle just the way I did here. However, exclude the boundary. One thing I want to stress is that if you did plug a point from the boundary into the function, you would see basically that you would end up with something like ln, for example, of 0, which is not a defined quantity. So exclude the boundary for that reason. So what is this all telling us? It's telling us that if I want to express the domain, I can express the domain. I would say that it's the set of all x comma y, so it's the set of all points, in other words. Remember, the vertical bar is read as such that. So this is the set of all x comma y such that x squared plus y squared is less than 4. In other words, it's the interior of the circle with the boundary excluded, because that would lead to taking the ln of 0, which is not a defined quantity. Okay, and that is it for me. Thank you so much for watching. Please leave a like and subscribe. I'll see you on another mathematical video.